Students, in the previous class, we started logarithms. Today, we continue the chapter logarithms. We will learn the concepts of logarithms, important formulae, and some problems on logarithms. This is in chapter real numbers of class 10. Let us start the problems on logarithms. Class 10, real numbers. Logarithms. Page number, pages 16, 17, 18, 19. 16, 17, 18, 19, and 20. These pages we can refer. Yesterday, we discussed the definition of logarithm. What is the definition of logarithm? If a power x, equal to n, then x equal to log n base a. This is the definition of logarithm where a is greater than 0, a is not equal to 1, and n is greater than 0, and a, n are real numbers. What is the meaning of this statement? Here, a and n are positive real numbers. Simply, we can understand that a and n are positive real numbers. Positive real numbers. Positive real numbers, and a is not equal to 1. A is not equal to 1. This is the definition of logarithm. Now, we will do some other problems. Yesterday, based on this definition of logarithm, we did some problems. Let us note down some important formulae in this topic. The first formula is log of xy to the base a, log of xy to the base a equal to log x to the base a plus log y to the base a. This is a very important result in logarithms. Now, how to prove this result? How to prove this result? Let log x base a equal to n, log y base a equal to m. From this m plus n equal to m plus n equal to log x base a plus log y base a. So this is equation 1. Now, by the definition of logarithm, log x base a equal to n. This implies x equal to a power n. Log y base a equal to m. This implies y equal to a power m. So we can write this from the definition of logarithm. Now we find the product xy. Xy equal to a power n multiplied by a power m. So this is equal to a power n plus m. A power n plus m. Now what is the definition of logarithm? If log x base a equal to n, then x equal to a power n. So this is the definition of logarithm. This is the definition of logarithm. From this, here in place of n, we have n plus m. In place of x, we have xy. So, from the definition of logarithm, from the definition of logarithm, we can write log of xy to the base a equal to n plus m. We can write this. How can we write this? This is by the definition of logarithm. Here, log x base a equal to n implies and implied by x equal to a power n. We have this. So, here in place of x, we have xy, and in place of n, we have n plus m, and in place of a, we have a only. So, you apply this here to this formula. The actual formula is log x base a equal to n implies and implied by x equal to a power n. So if this formula is applied to this xy equal to a power n plus m, then we get log xy base a equal to n plus m. This is 2. This is 2. But from equation 1, m plus n equal to log x base a plus log y base y, log y base a. And from equation 2, m plus n equal to log xy base a. So therefore, from these two equations, from equation 1 and equation 2, from 1 and 2, we get m plus n equal to log xy base a equal to log x base a plus log y base a, log y base a. So we can conclude that log of xy base a equal to log x base a plus log y base a. So this is very important formula. We have derived this important formula from the definition of logarithm. Dear students, let us discuss this process of proving the important result. Here we have log xy base a equal to log x base a plus log y base a. We have to prove this result. This is very important result. Now let us assume that log x base a, log x base a equal to n and log y base a equal to m. So let us assume this. So if we assume this, we can write m plus n equal to log x base a plus log y base a. This is taken as equation 1. Now, by applying the definition of logarithm, log x base a equal to n implies x equal to a power n. This is a very important result. And log y base a equal to m implies y equal to a power m. This is by the definition of logarithm. This is by the definition of logarithm. Now we considered the product xy. We considered the product xy. Therefore, xy equal to a power n multiplied by a power m. So therefore, we can write xy equal to a power n plus m. Now, comparing with the definition of logarithm, here we have log x base a, log x base a equal to n implies and implied by x equal to a power n. This is the formula. In this, we have the terms in place of x, we have xy. In place of n, we have n plus m. In place of a, we have a. So we compared this with the given formula. From this, we can write log xy equal to n plus m. This is equation 2. So from equation 1 and equation 2, we can conclude that m plus n equal to log xy base a. This is from equation 2. Log x base a plus log y base a. This is equation 1. This is equation 1 and this is equation 2. So hence we can conclude that log xy base a equal to log x base a plus log y base a. So hence the result is proved. Now we consider next result and we will prove it. This is very important result in logarithm. Logarithm of x by y to the base a equal to log x base a minus log y base a. So these are very important results. So we must prove this. So let us assume that log x base a equal to n. Let n equal to, otherwise I will write log x base a equal to n. Log x base a equal to n and log y base a equal to log y base a equal to m. So from this, by the definition of logarithm, this can be written as x equal to a power n. We can write, and from this, by the definition of logarithm, we can write y equal to a power m. Now, now we consider x by y. X by y equal to a power n by a power m, that equal to a power n minus m, a power n minus m. Now, by the definition of logarithm, by the definition of logarithm, here x equal to a power n implies and implied by log x base a equal to n. So this is the definition of logarithm. Here, in place of x we have x by y, and in place of n we have n minus m. In place of n we have n minus m, and in place of a we have a only. So now You see this formula. This is of the form x equal to a power n formula. Compare this with the formula x equal to a power n. Then you get log x base a equal to n. So from this we can write n minus m equal to log x by y base a. So this is by the definition of logarithm. You just compare with this definition. Here we have x by y in place of x, n minus m we have in place of n, a in place of a. So you just compare this. You will understand how to write this step. So now this is equation 1. This is equation 1. Now we write n minus m equal to, what is n? Log x base a. Log x base a minus what is m? Log m log y base a. So this is log y base a. So this is equation 2. From equation 1 and equation 2, we can write n minus m equal to log x by y base a equal to log x base a minus log y base a. So we can conclude this. Therefore, logarithm of xy to the base a equal to logarithm of x to the base a minus logarithm of y to the base a. So this is very important formula. So we have derived this. So let us try to understand how we have derived this important result. So here we have to prove that log x by y equal to log x by y to the base a equal to log x base a minus log y base a. We have to prove this important result. To prove this important result, we assume that log x base a equal to, n. From this, by the definition of logarithm, we can write x equal to a power n. Now, we assume that we assume that log y base a equal to m, and by the definition of logarithm, we can write y equal to a power m. So this is what we assumed. We assumed that log x base a equal to n and log y base a equal to m. From this, by the definition of logarithm, we get x equal to a power n and y equal to a power m. Now, we consider x by y. So, when we consider x by y, in place of x, we can write a power n. In place of y, we can write a power m. So, if a power n by a power m is there, then we can write a power n minus m if n is greater than m. If n is greater than m, we can write this. So if we can write this x by y equal to a power n minus m, then we apply the formula the definition of we apply the definition of logarithm x equal to a power n implies and implied by log x base a equal to n. This is the definition of logarithm. In this definition, in place of x you have x by y here. In place of n we have n minus m. In place of a we have a. So let us observe this. X by y equal to a power n minus m is of the form x equal to a power n. So then by the definition of logarithm we can write log x base a equal to n. So here we can write log x by y to the base a equal to n minus m. So this is taken as equation 1. Now in place of n we can write log x by a. This is by the definition of by in the starting itself we assumed that n equal to log x base a and m equal to log y base a. This is by our assumption. Therefore n minus m equal to log x minus log y base a. But we have proved that n minus m equal to log x by y to the base a. Therefore, we get this final result. So this is a very important result. Now, we consider another important result. Prove that log x power n to the base a equal to n log x to the base a, where a x and n are positive real numbers, and a is not equal to 1, and a is not equal to 1. So here we have to show that log x power n to the base a equal to n log x base a. Now let us suppose that let log x to the base a equal to n. Log x to the base a equal to n. Now, by the definition of logarithm, by the definition of logarithm, we get x equal to a power n. X equal to a power n. Now consider consider x power n. So this is equal to x multiplied by x multiplied by x multiplied by x multiplied by and on n times. So x is multiplied for n times. This is equal to a power n multiplied by a power n multiplied by a power n multiplied by a power n and so on. We multiply a power n for n times. So we must write it is for n times. Here also we underline this. It is for n times. So this is equal to a power n plus n n plus n plus n plus and so on n times. So if n is capital N is added for n times, we can write this is equal to a power n capital N. A power n capital N. But what is n? N is log x base a. In place of n, we can write log x base a. This is equal to a power n log x to the base a. So you must remember a is the base and this is the power. So here we have written this is equal to a to the power of n log x to the base a. This is x power n equal to x power n equal to a power n log x base a. Now we write the definition of logarithm. What is the definition of logarithm? If a power x equal to n, then x equal to log n base a. So this is the definition of logarithm. This is the definition of logarithm. Now here in this formula, in place of a, in this formula, in place of a, you have x power n. X power n. So if a power x equal to n, then x equal to log n base a. Now we have proved that x power n equal to a power n log x base a. So let us See this? We have to prove that log x power n base a equal to n log x base a. So now we apply the definition of logarithm. By the definition of logarithm, by the definition of logarithm, we get n log x base a equal to log x power n base a. Now let us compare the terms with respect to the actual definition. A power x equal to n. A power x equal to n. So here we have x power n equal to a power n log x base a. Now let us compare with the formula. So this is n and this is x. So n equal to a power x. So here in place of n we have x power n. In place of x we have n log x to the base a. So in place of a we have a only. So let us compare this with the given formula. A power x equal to n implies and implied by x equal to log n base a. Now actually here we have x power n equal to a power n log x base a. So by comparing with this a power x equal to n, we can write x power n. In place of x power n, we can write n and this is equal to a power x. So this is what we have. Here we can compare this with n equal to a power x. If you compare this with n equal to a power x, here in place of n you have x power n, in place of x you have n log x base a. So in place of a you have a. So this can be written as x equal to log n base a. So what is x value here? Here this is x. X is n log x base a. N log x base a. N log x base a equal to logarithm of capital N. What is capital N? A power x. A power no. Capital N equal to x power n. Capital N equal to x power n. So in place of capital N we can write x power n to the base a. This is how we have written the result. We have written the result. Therefore we can write log x power n to the base a equal to n log x to the base a. So this is very important result. We have proved this. Now we start problems on logarithms. Express this is do this from page number 19. Page number 19. Do this. Okay, let me explain the result in briefly. Prove that log x power n. Prove that log x power n to the base a equal to n log x to the base a. This is very important result. We have to prove that log x power n to the base a equal to n log x base a. This is what we have to prove. Here a, x and n are positive real numbers. A is not equal to 1. A, x and n are positive real numbers and a is not equal to 1. Now we suppose that log x to the base a equal to n. We assume that log x to the base a equal to n. Then by the definition of logarithm, we can write x equal to a power n. Log x to the base a equal to n, it is assumed. By the definition of logarithm, we can write x equal to a power n. Now, consider x power n. Consider x power n. X power n equal to x multiplied by x multiplied by x multiplied by for x multiplied for n times. X multiplied by for n times. So that means in place of x we can write a power n. So from this we get the a power n is multiplied for n times. If a power n is multiplied for n times, we can write a power n plus n plus n plus and so on n times. So if capital N is added for n times, we can write n a power n n. So but we know that n equal to log x base a. N equal to capital N equal to log x base a. So we can write x power n equal to x power n equal to a power n log x base a. X power n equal to a to the power of n log x base a. We can write this. Now let us consider the definition of logarithm. If a power x equal to n, if a power x equal to n, then x equal to, if a power x equal to n, then x equal to log n to the base a. This is the definition of a logarithm. So here we have noted down x power n equal to a to the power of n log x base a. So we compare this with the standard formula. Standard formula. If we compare it with the standard formula, then you get n equal to a power x. So that means in place of n, you have x power n. In place of x, you have n log x to the base a. In place of a, you have a only. So by applying the logarithmic formula x equal to log n base a, if n equal to a power x, then x equal to log n base a. So in place of x, you can write n log x base a equal to log n. In place of n, we can write x to the power of n. We can write x to the power of n. And to the base a, we can write a only. So this is how we have applied the definition of logarithm to the given problem. So hence we got that n log x to the base a equal to log x to the power of n base a. Therefore, we can conclude that log x to the power of n base a equal to n log x base a. So this is the conclusion. Now we do solve the problems based on this formulae. Refer page number 19. Do these problems. Express the logarithms of the following. Express the logarithms of the following into the sum of the logarithms. Into the sum of logarithms. First one, 35 multiplied by 46. Second problem, 235 multiplied by 437. Third problem, 2437 multiplied by 3568. So now we note down the formula. Logarithm of xy to the base a equal to log x to the base a plus log y to the base a. Where x, y and a are positive real numbers, or positive real numbers, and a is not equal to 1, and a is not equal to 1. So we have noted down the formula. Here we will keep this formula in a box. So the formula is log of xy, log of xy to the base a equal to log x to the base a plus log y to the base a. This is the formula. Here x, y and a are positive real numbers. A is not equal to 1. So let us solve the problems. The first problem. 35 multiplied by 46. So here x equal to 35, y equal to 46. Here x equal to 35. So we know the formula, log of xy to the base a equal to log x to the base a plus log y to the base a. So logarithm of 35 multiplied by 46 equal to if there is if the base is not mentioned here, we suppose that the base is 10. So this is base 10 equal to log 35 to the base 10 plus log 46 to the base 10. Here the important thing what you have to remember is, if the base is not mentioned in the problem, then we take the base a equal to 10. We take the base a equal to 10. So I will explain about the base of logarithm in another class. We can take the base is 10 and e. Logarithm it is, I will explain all those concepts. So in this class, let us solve the problems using this formula. So here 35 multiplied by 46, we have taken a logarithm. So logarithm of 35 multiplied by 46 to the base 10 equal to log 35 base 10 plus log 46 base 10. This is by using the above formula. Similarly, we can solve the next problems. The second problem, 235 multiplied by 437. So let x equal to 235, y equal to 437, and the base a equal to 10. Base a equal to 10. So we know the formula, log xy to the base a equal to log x to the base a plus log y to the base a. Now by using this formula, we can write logarithm of 235 multiplied by 437 to the base 10 equal to logarithm of 235 to the base 10 plus logarithm of 437 to the base 10. So hence we have written the given problem as the sum of logarithms. So log of xy to the base a equal to log x to the base a plus log y to the base a. So this is an important result. Now we solve the third problem. Third problem, 2437 multiplied by 3568. So suppose that x equal to 2437, y equal to 3568, and the base a equal to 10. If the base is not given in the problem, we assume that the base is 10. This is very important. All students must remember in class 10, if the base is not given, then we consider the base as 10. Now we note down the formula log xy to the base a equal to log x to the base a plus log y to the base a. So using this formula we can write logarithm of 2437 multiplied by 3468 to the base 10 equal to logarithm of 2437 to the base 10 plus logarithm of 3468 to the base 10. So we completed these problems. Now next model. Dear students, I would like to explain all of you why we take the base a equal to 10. So the base in logarithm can be taken as 10 or e. I will take a separate class on this concept, and I would like to explain the definition of logarithm using a graph. So using what is the graph of logarithm, I would like to explain all those concepts in detail in another class. So let me explain the problems today now. Express the logarithms of the following. Logarithms of the following into the difference of logarithms. into the difference of logarithms. Do this. Page number 20. Page number 20. Students can refer page number 20. Do this. The first problem, 23 by 34. Second problem, 373 by 275. Third problem, 4525 by 3734. And fourth problem, 5055 divided by 3303. So now we note down the formula of logarithms. Formula: logarithm of x by y to the base a equal to log x to the base a minus log y to the base a, where x, y, a are real numbers are real numbers and a not equal to 1. So this is the formula. Based on this formula, we will solve the above problems. So division of two numbers is given. So using logarithms, we can expand this. Now the first problem, 23 by 34. Let x equal to 23, y equal to 34, and the base a equal to 10. Base a is taken as 10 in all problems in class 10. Unless and until it is not mentioned, we should take base a equal to 10. So now we note down the formula: log of 23 log of x by y to the base a equal to log x to the base a minus log y to the base a. Using this formula, we can write log of 23 by 34 to the base 10 equal to log 23 to the base 10 minus log 34 to the base 10. So this is how we apply the given formula log x by y to the base a equal to log x to the base a minus log y to the base a. This is the formula we apply. Now we consider the next problem. The second problem.